Hello everyone, and welcome to Geometry Lesson 2.6, Geometric Proof. So first let's talk about what a proof is and why we might need it. Basically, a geometric proof is a logical bridge that takes you from your hypothesis or whatever starting information you're given, and it takes you across to the conclusion. And you have to create this chain of logical steps, and you have to make it so that you can follow one step to the next. So you have to take baby steps sometimes. And you have to justify each logical step with a reason. Now, you are allowed to use symbols and abbreviations, but they must be clear enough that anyone would understand them. So what we're going to do to kind of introduce the idea of geometric proof is we're going to take a look at some steps, and we're going to try and figure out why they could say what they said. So we need to come up with reasons for their steps in their proof. It says, write a justification for each step, given that angle A and angle B are complementary, and angle A is congruent to angle C. So when the things that are up here, these given facts, are used in the proof, next to them, you're going to write the word given. So the first thing you're going to do is you're going to pause the video, copy this down, and then try to find these two given statements in the proof and write the word given next to it. Okay, so hopefully you got given for the first step and given for the third step. Now, the next thing we're going to do is we're going to take a look at this first and second step. And we're going to say, in the first step, they said angle A and angle B are complementary. And then from that, they figured out that angle A plus angle B is 90 degrees. So try and figure out how they knew that if they added these together, they would get 90. Okay, so try and figure out how they knew that, and then press play to check your answer. Okay, and they knew this because the word complementary was used. And every time that you use what a word means, that's a definition. So this is the definition of complementary angles. Okay, now what we're going to do is we're going to try and figure out how to get from step 3 to step 4. Notice it says angle A is congruent to angle C, and then they said that the measurements are equal. So think about how they knew that the measurements were equal if we knew the angles were congruent. Anytime they switch from congruent things to equal things, they're using the definition of congruence. So this is the definition of congruence. You can write congruent angles there as well. And anytime they switch from equal things up to congruent things, it's still going to be the definition of congruence. So now we have to take a look at what we have and see why we know that this statement has to be correct. So my suggestion would be to try and think about how this statement in 4 might relate to some of the other statements that we previously said and how we could possibly get statement 5 from those. Try and combine 2 statements to get statement 5. Okay, notice how statement 5 looks very similar to statement 2. And all they did is they switched angle A for angle C. And notice we're allowed to do that because A is equal to C. So I'm allowed to replace angle C for angle A. And the thing that lets me replace something with something that it's equal to is the substitution property of equality. Okay, now for the last step, try and figure out why, if I know that angle C plus angle B, I get 90. Why does that mean that they're complementary? Okay, and that's because of the definition of complementary angles. Okay, because I'm using what the word means. If I know they add to 90, then I know that I can use the word complementary to describe those angles. So let's take a look at some theorems that are useful for our proofs. Okay, now in the previous example, we used given statements, we used definitions, and we used some algebraic properties. But another thing that we're allowed to use are theorems. These theorems are statements that somebody proved at one point in time. And once a theorem has been proven, you can use it as a reason in a later proof. So our two theorems are the linear pair theorem, and it says that if I know two angles form a linear pair, then those angles are supplementary, which really makes sense if you think about what a linear pair is. A linear pair has a straight line on one side, and there is a ray coming out of it for two angles that are adjacent. Now, they're adjacent and they form a straight line or a 180 degree angle. That makes them supplementary because they're right next to each other and they form 180 degrees. So it really makes sense if you think about it. And notice that the theorem is named by what it's talking about. It's talking about things being a linear pair. So it's the linear pair theorem. In the other theorem we have, it's called the congruent supplements theorem. If you know that two angles are supplementary, like 1 and 2 are supplementary, and you also know that 2 and 3 are supplementary, well, that means that 1 and 3 have to be the same measure. For example, if angle 1 is 80 degrees and 2 is 100, and I know they add to 180, this 2 would also be 100, so how much should the angle 3 be? Well, it should be 80, which is the same as angle 1, okay? So it's kind of like syllogism a little bit, but those two other angles that are supplementary to angle 2 are going to be congruent. So let's take a look at what a two-column proof is. Now, we were using this a little bit when we did algebraic properties and algebraic proofs, but we're really going to use them with geometric proof. Okay, so a two-column proof is really just a way to organize your steps in your proof. The first step is almost always the given information. So whatever it says was given is copied exactly as it is on the left side, and then you write the word given next to it. And then at the very end of the proof, the last statement on the left side should be what they told you to prove. And then on the right side, you never write the word prove or proven. You have to give a reason for why that's true. So you can't use the word prove or proven in your proof. You actually have to give some reasons. Now, the left column is always going to contain the steps, and the right column always contains the reasons. So let me show you an example of what a two-column proof would look like, and we're going to fill in a few steps. Okay, this is a proof of the linear pair theorem. So it says given angle 1 and 2 form a linear pair. Notice that is what they started with here in step 1. And they said to prove angle 1 and 2 are supplementary. That's what they have here in step 6. And we just have to figure out what belongs in A, B, and C. So notice they said they form a linear pair. It says BA and BC form a line because that's what a linear pair does. And they told you that angle ABC is 180, and that's the definition of a straight angle because they form a line. So now they want us to use the angle addition postulate. So see if you can figure out how to use the angle addition postulate with what's in this picture here to write an equation. Okay, the equation I wrote is this. The measure of angle 1 plus the measure of angle 2 equals the measure of angle ABC. Because the angle addition postulate lets us take this angle plus this angle, and it adds to the big angle. Remember, they're adjacent angles added together get you the big angle. Or part plus part equals whole. Now, in step 5, they want you to use substitution, and they gave you the hint of using steps 3 and 4. So see if you can figure out what in step 3 can be put into the equation we had in step 4. Okay, and I just replaced ABC with 180 because notice angle ABC is 180 degrees, so I replaced it in there. Now for the last step, they said angle 1 and angle 2 are supplementary. How did they know that? What in this previous step told them that 1 and 2 are supplementary? Okay, and that's the definition of supplementary angles because they looked at what the word means. Supplementary means that they add to 180 degrees. So basically, anytime you're changing from symbols into a specific term word, you're going to use a definition of that word. So we still have a few more examples, so make sure you watch my next video.